welcome to episode 2 of Archetypical. Glad to have you all here tuning in. This week we have Ken Sanford joining us all the way from sunny California, and Marty Gaupp down in San Antonio there in Texas. Both of them are senior directors in our analytics practice, specifically with data science. And we're excited to have them here and welcome you two.
Thanks for having us.
Thank you.
So why don't we get started kind of same as last time that we did for episode 1, but have you guys kind of give a quick background of really your career and then how you even joined Archetype and what your role is here now. So why don't we start with you, Ken?
Sure. So I'm Ken. I'm a reformed academic economist. I started off in academic economics. And I always wanted to get into more data science. I happened to write a dissertation using some big data practices and eventually found my way to SAS. And so SAS sort of invented modern analytics, was the OG company in analytics, and spent time there before transitioning to a couple of the startups in the data science technology space. And so here at Archetype, my role is primarily a technology and process and people matching. And so I run a lot of our AI roadmaps, machine learning roadmaps, parts of the practice, plus some of our tech integration, tech questions. So awesome. That's me.
Awesome. Marty.
So I got my start in college studying something called operations research, or OR for short. And it's really all about the practical application of analysis. And I spent 22 years on active duty in the Air Force, where I practiced OR in various different places, from training command to the Pentagon to overseas in Afghanistan on a battle staff. A lot of time in the classroom as a student and a teacher. I taught economics, math, ops research, statistics, all those fun quantitative subjects. I retired about 6.5 years ago and went to work for a company called USAA. They're a bank and a insurance company that caters to the military. And that's really where I would say from a practical standpoint, I really got into data science, leading teams of data scientists, doing things in the insurance space, in the banking space, in the risk analysis space. I'm pretty new here at Archetype, not even 6 months yet, but I was brought on to help with just leading the data science practice here with Ken, where Ken is a little more on, the business development and client facing. I work a little bit more on the technical side of things, really helping other members of the data science community here with some technical leadership, but really a lot of mentoring and also just, the thought leadership and the strategic direction for data science here.
Awesome. I've always found it like your two's backgrounds are very different when it comes to where you guys have come from obviously Ken coming from more the academic world, and then Marty coming from more military. Is the way that you guys view data science the same, or is there almost kind of you guys have a nice balance in that? I've kind of always wondered with the different backgrounds, how is data science different to you guys?
It's good. It's a fun question. And I not to speak for Marty, but our take on data science is shockingly similar.
I would totally agree.
I think it comes from, our shared background in economics and operations research. Right. So, after formal training in econ, which you get a lot of mathematical optimization in that, when I was at SAS, I worked alongside a lot of the OR folks and statisticians. And so I got a healthy dose of that type of thinker. And it was always pretty well aligned with economics. And part of the reason why I think we share that same view is that, most data that you work on in data science are passively collected or secondary sort of observational data, right? They're coming from a business process which we can't control, right? So we come to these data having not had any influence on how they were generated, or very little. And so we just have to do the best with what we have. And that's part of the social science, economics, operations research training toolkit. Marty?
Yeah, I completely agree. I think the thing I really appreciate about the way Ken and I work together is it's very practical minded. It's about looking at what the real problem a client has and figuring out a solution to it. Not coming with a solution and then trying to help a client find problems that solution can solve. And it's definitely something the military's really good at, because we've got lots of problems. We don't have time to pontificate and philosophize. It's an 80% solution on time is better than a 100% solution late.
Yeah,
one of my earliest bosses.
Yeah, it's a constrained maximization problem. Everything. Exactly. So like in economics, that's what you always study, right? Like, how do I get the most bang for the buck, or how do I make as much money based on much stuff I can make? Same idea, where our clients come to us and go, okay, well, we want to solve this problem. Great. We're going to need to box that thing so that there's some value, like you get value, and, we can do it at a reasonable cost, for both parties. So, yeah, I mean, it's maybe that's it. It's constrained optimization.
There you go.
Lagrangian.
Love it. Yeah. Now, throughout your guys' career, I'm curious how you've seen maybe data science itself change, or maybe even the definition of it from before to now, or even just the way that it operates. How has it changed since you guys have started in the data science realm?
Well, I think data science as a word didn't even exist until really about 10 years ago. And what's kind of funny is since we both have ops research in our background, I mean, OR was founded during World War II, really by the military, to get better at doing the craft of war. And they have societies, they have groups that formed, professional societies, which have now in the last decade or so rebranded themselves as data scientists. So data science is just kind of the natural evolution, in my opinion, of what happened to quantitative analysis. It's benefited hugely from the cheap and really powerful computers and easy memory, and then big data. I mean, big data meant we had to look at problems differently. Now, what's happened, I really think, over the last decade is it's become easy to be a data scientist, but you're not really a data scientist, because there's platforms and tools out there that you can do literally free online and do data science work. But I would say, again, kind of the academic in me says, you got to take the time and invest to really understand what's going on under the hood. And that's what, in my opinion, separates the real data scientist from the person who can play data science a little bit. I think there's nothing wrong with people wanting to do analysis. I mean, I'm a huge evangelist for more people doing quantitative analysis, but not every quantitative analysis is a data science project. It's the depth that you bring, and it's an investment. It really is. You've got to learn how to do math. You've got to learn some pretty complicated, programming or statistics. And so, that's where I think data science has evolved. The other thing that's evolved is the fact that you don't have to go to school anymore. There's so many free online programs. There's these things called massively open online courses that are run by companies like Coursera or edX, where anybody can learn data science. It's amazing to me how many non-technical people get into data science because they have a problem where they go to school and they have to analyze data, and they quickly realize, oh, I got to get smart on some of this data science stuff to analyze my data. And they become data scientists without really thinking they were gonna do that, or necessarily wanting to do it. But it's a survival thing for them in school.
Yeah. Neat. What about you, Ken?
Yeah. So at least in my career, I think when I started, the term data science was barely used. It was mostly, you come from a statistics background or possibly economics background or OR background. Now, now you come into it with data science, whatever that means. And sadly, if you do pursue one of those, what we'll call pure disciplines of data science, you do have to sit with your thoughts a lot around data. And you begin to understand the problems with data, and meaning, like, not every problem is a prediction problem. Like, there's lots of problems out there that need high horsepower that don't end up as an API to make a prediction in real time. Now, that's certainly part of data science. And kind of when you initially asked the question, my initial thought was, like, back in the day, data science was insight only, and now data science is, let's make an operational decision based on this. Oftentimes that ends up as something real time, right? Like, can I put a real time calculator on my website that tells me, whether or not I should approve this loan, or is this a fraudulent transaction or not? Those are data science questions manifest as like a last moment operational decision. It used to be that data scientists sat in the back room. Now data scientists are actually inside product, right? We work with a customer, Marty and I work with a customer where their entire product is a data science question. That's the type of company that didn't exist a long time, not 15, 20 years ago. And if you look at these digital native companies, the ones like the Ubers and the Facebooks and the types of Stripes, everybody that works there thinks like a data scientist. They may not all be data scientists, but they're all thinking, okay, how can I automate this decision using some best practices around data? And I'd say that's a big difference than 15 years ago when I started doing this.
I feel like, from my very little bit of experience of base, I'm not a data scientist. I'll say that publicly. I can play one on TV at times, but it seems like in the past, and even more recently still, data scientists still had to code, where now there's like, I know, Ken, back from your Dr. Data Days videos that we've made, you talked about like the point and click type of data scientists, or the software tools. Is there a difference there of like data scientists who can code and data scientists who are more now doing more like point and click things? I
don't think, look, the quality of work from point and click or from code is irrelevant. I will say that the practice of coding, regardless of the language that you write in, changes the way that your brain works with looking for patterns and looking for simplified versions of the world, right? And so coders instinctively become more efficient, and even like, I guess maybe I'll say this, even really good point and click data scientists were at one point coders. Right? Like I can't write Python as well as I can write Stata, for instance. Like, Stata was my OG language, right? And if you put a gun to my head and sat me down in front of a computer and said, like, Ken, do some analysis, I could open it up in Stata and still do all the same stuff, like 15 years later, because that's what my brain was thinking. However, if you give me a tool like Jump or Data IQ or a data robot, I can point and click my way through how I would have done code, if that makes any sense. But having not had that coding capability, it's really hard.
I think what coding allows you to do, there's some great point and click tools out there. There have been for decades for simulation analysis and different quantitative disciplines. But what coding allows you to do is move beyond when you hit that wall of, oh, there's not a button I can click to do this. And coding lets you do the customization. And I totally agree with what Ken said about it. It makes you think differently. Look, at a bottom line, computers are stupid. They do exactly what you tell them to. And you have to figure out what to tell them to do in order to write a program, which makes you think about, what am I really wanting to do here? And that thought process is what's important. It's like teaching a child how to do a new task, tie your shoes. If you just tell your kid tie their shoes, they don't know what to do. You have to teach them an overhand knot, a bow, maybe a double knot, because the rope is really slippery and always comes untied. All these things. And then you got to teach them, well, what is string? Because they look at their shoes and they're made of Velcro. They're like, what am I tying here? These are the kinds of things when you do some coding, you learn very quickly. Oh, wow, I got to be very specific on what I do. Again, I think point and click can get us a lot of the way there. Yeah. But I think the strongest people in the point and click world are those who can resort to code when they need to. It may not be their first choice, but they don't hit a brick wall when the clicking just stops.
Well, and you're constrained. I mean, you think about one of the early things you learn how to do when you start to code is sort of text replacement, and then that's followed quickly by loops. And I remember learning loops because I wanted to run a whole bunch of analysis a whole bunch of times. And I'm like, there's got to be a faster way to do that. In a point and click world, that becomes really hard. Like there's really not much of a concept of looping per se in a point and click world. Run this bajillion times, sometimes by groups, there's a point and click button for that. But if I wanted to loop over things that are not by groups, I'm stuck, right? And so then I'd have to learn how to write some code. But I wouldn't have even thought about it if I wasn't lazy, right? Like a coder sort of like simultaneously makes you lazy and makes you productive. What's the Bill Gates says, if I have a really hard problem, I always look for the laziest programmer, because he or she will figure out the easiest way to do it, right? And it makes a ton of sense.
Well, and Ken's example of a loop is a perfect case point. With a loop, do you test your condition at the beginning of the loop or the end of the loop? Totally makes a difference. In a point and click world, that may not be apparent to you at all. You just do a feedback loop. Whereas in a coding world, if I check the condition at the beginning, that's a different kind of loop than if I check it at the end. And, depending on the situation, one may be better than the other, but coding makes you think through logic like that. And it doesn't matter what language, any language. I mean, there's actually, I have some younger kids, and when I was working on some coding with them, there's like point and click coding programs out there where instead of actually writing code, you just drag icons that represent code, and they kind of come together like puzzle pieces. And it teaches you the logic behind coding. And then it's an easy step to just remove those icons and write if instead of, an if icon.
Marty, is funny. I'm thinking back on why did I ever start coding? And I remember it was because I think I wasn't able to take the license of that particular software and put it on my laptop. But I realized, I got a text file. I got a text editor. All I got to do is just write a bunch of text, and I could just port it around all over the place. And I think that's the reason why I started. I got away from the UI all those years ago. It's funny.
Love it.
Just text pad.
So I guess one of the main questions I want us to answer in our discussion here is the aspect of obviously the buzzwords that every single firm is throwing around of data science, artificial intelligence, machine learning. Is there a difference? Are they the same thing? What's up with that?
So I actually had to research this a little bit because there's opinions, and then there's more kind of agreed upon truth. And here's the way I would put it. AI is the big picture thing. AI is just what the word says, artificial intelligence. You're trying to mimic human behavior. It's Skynet. It's, what's the different sci-fi movies that, it's HAL. It's that kind of stuff. We're not there yet. There's a famous scientist named Alan Turing. He created something called a Turing test. It's when we can pass the Turing test, we've created artificial intelligence. And the Turing test is basically you're talking to someone behind a curtain, and you don't know if that person behind the curtain is a person or is a computer. That's the Turing test. Then I think data science is a subfield of that, but it includes more than just mimicking human behavior, because it includes, it's the data in the science. It's visualizing the data. It's telling a story with the data. It's getting insights from those data. It may not be intelligent. It may be as simple as you're binning the data in a certain way by color, and you quickly realize, oh, I've got more red than I have blue. That's insight I got from doing data science. And then machine learning, I would say, is a subfield of AI. It's a tool in data science where instead of, traditional programming is you tell the computer what rules and relationships to follow. It takes inputs based on those rules and produces outputs. Machine learning kind of turns that on its head and says, I got inputs and outputs. I know there's something going on in here, but I don't know what it is. Let me give the computer a ton of examples and let it learn what the relationship from input to output is. And so it basically writes the program for you. It's not writing code, but it's telling you this is the relationship between input and output. That's the way I look at it. So if you want to draw a diagram, AI is this big bubble, machine learning is a small bubble within it, and then data science kind of includes AI and machine learning, but it also goes outside of it because it includes some things that neither one of those two include.
Yeah, I think that's perfect. I mean, one thing I'll add is when I think of machine learning, I think of a system which is constantly evolving with new data and has the human sort of out of the loop of that model getting better. And so there's some sense that there's automated retraining and deployment of a model. An AI system is really a collection of of machine learning algorithms playing whack-a-mole, right? And that's kind of where we are, right? Where, okay, well, we've got a model that sort of explains all this behavior, and when presented with, let this model take charge. And then there's some weird observations that we write a business rule around, and we play whack-a-mole. And then we just make a really good whack-a-mole game, and then it mimics a human making these decisions. AI tends to be really great for lots of small value decisions, right? When it comes to a couple really big decisions, human intuition does a pretty good job, right? And so there still needs to be a heck of a lot of human intuition in data science, which is something Marty and I talk about all the time, right? I mean, it's crazy.
The art. You need the art in data science, not just the science. It's the creativity that a computer can't be creative yet. A human can be creative and see things that a computer will never see.
Yeah, you go back to what's in data science. Well, it's a collection of tools. Some of those tools are, computer sciencey. Some of them are the highly predictive modeling. Some of them are A/B testing and experimental design and basic statistical analysis and concepts of optimization. Those are, what's called the data generating process. Where did these data come from?
And explaining it, and storytelling and visualization is all part of it too.
Is that value? We saw this with a client just the other day. They got a bunch of cells with no value in it. Is zero? Is that it's missing? Is that they didn't collect anything before that? Did they change the skew from one day to the next? We don't know, right? And the computer doesn't know that either. And so you've got to inject intuition, sort of, and that takes an interviewing process and some interrogation and asking your subject matter experts, what the heck is this, right? And then all right, we think it's mostly this, so we feel okay putting zeros in. And why does that matter? Well, because the forecast that we come up with if it's not a zero and we call it a zero, we're going to get some wonky answers.
Yeah, so it's kind of the same that I've always said in general from a full modern analytic solution. It doesn't matter what technology you put on top of bad data, bad processes, you're going to get a bad result. Same thing with modeling and with
you're going to just get a more accurate bad result.
Exactly.
Really, with a better tool. That's all you do is you get a more accurate bad result.
Exactly.
Sometimes faster. Definitely more expensive.
So I guess the next question is why? I mean, it seems like it's just marketing going on that's blurring this line of AI, machine learning, and data science, of really just people using the buzzwords to try to build up hype.
I think so. Yeah.
Yeah. Look, executive leadership is always looking for a panacea to bump stock price or increase profitability. And so I can't really blame the world for looking for ways to do that, because data science and analytics has got super high ROI. And so, but with all things, you've got to temper expectations and realize sometimes that's in-house generated, sometimes it's purchased as pieces of technology. Marty and I talk about and deal with that all the time, where there's different layers of build or buy, right? There's if I'm a company and my transactional system provides a nice predictive model, maybe I use that. Maybe I look to a third-party tool to augment my transactional system to provide a prediction that is core to my business. Maybe I just build the whole thing from scratch. Now, what I do there kind of depends on what the core business is, right? If for instance, if my core business is I'm an oldish bank, okay, I don't need to build this stuff from scratch. It makes no sense. If my operational system that runs my ledger provides a really nice job of cash forecasting, maybe I use the tool that comes out of my operational system. However, if I've got a staff, maybe I'm an aspiring to go public bank, maybe I use some pre-ready-made tools to do that same sort of thing. If I'm a fintech on the bleeding edge and I really don't want to encumber my IP, well, then I build the whole thing from scratch using, sticks and twigs and nails, right? But it's a decision. It's a decision that companies need to make case by case.
Yeah,
and they have to be willing. The companies have to be willing to invest in the resources, which means tools. So the software or the compute hardware and the mental tools, the people who have the capability to do this. And that could be hard to find because they may have the technical skills, but they don't understand the data or the domain. And that's going to take time for them to learn.
That's something that I think that we at Archetype do a pretty good job of, is setting expectations and helping companies along those first few hires. Those first few hires are really difficult because, remember, the executives are not data scientists themselves. They read Fortune and the rest in Forbes and all the rest of them, and they're trying to bring data science on, and so they go out and they hire somebody that's claims to be data science. And the truth is, and there's a lot of charlatans out there that don't, they've never really coded in anything, right? Or they haven't seen these sets of problems before. And you can get hoodwinked pretty easily, right? And so having some folks that have been around the block a little while to vet, all right, this is the type of person you actually need based on what you're willing to pay, yep. Right? We provide that as a service, and I think we do a pretty good job of it.
Yeah, no, it makes sense. And that's, even in kind of some of my talent acquisition, trying to find data scientists, and there's so many people, like you said, Marty, at the beginning, that call themselves data scientists, that really are not data scientists. And it's just really being able to pick through the weeds and find the gem of people who actually really understand data science isn't the easiest thing in the world at all.
It's not
taking a 1 hour data science boot camp does not make you a data scientist.
No.
And it's shocking how many people will make that claim.
Well, it's also, there isn't it doesn't seem like there's like as much of a tiered title differentiator of data scientists. So like,
well, data science didn't exist in college until, I mean, real recently. That's the thing. And that's why I said earlier, I think you're going to see a lot of your data scientists come more out of informal training programs than the formal academic education programs.
Yeah.
I mean, arguably one of the best data scientists who ever worked for me had a bachelor's degree in IT. And when I told him he needed to get a master's degree, he looked at me and basically said, why would I bother? What are they going to teach me that I don't already know? And he was an incredibly humble person. He was not saying this with any arrogance. He was just very matter-of-factly, and I couldn't say anything to him.
I mean, they all come from different subdisciplines, and that kind of does skew them on how they become a data scientist, but it definitely makes them know one area really well. I'm close to a number of different academic departments that have built various forms of data science degrees and certifications, and they all fight internally, like with other colleges, right? So I mean, within a university setting, so you might have an analytics data science bachelor's or master's coming out of math, and then there's one in economics that's called something slightly different. They're all fighting about like how to cross list these different courses. It's a mess, and will probably continue to be a mess. Here's the reason: data science is an enormous discipline. It's like getting a major in 5 things plus having some subject matter expertise that you're never going to get in college, because you don't learn anything about that in college, right? So it's hard. And then on top of it, we've got executives, God love them, but they're like, yeah, I need to know this, and they got to know as much about the business as me. They got to know more about computer science than my IT department, and they got to understand all the analytics stuff, holding a bunch of tools, right? And I'm like, well, what do you?
And I'm looking for an entry-level person.
Yeah, like this person's this person better make more money than you, and then they freak out. I'm like, well, they know way more than you. Like you need a team.
Yeah. Oh, totally.
You need a team. You got to build it.
And then the worst part about that is if you find that person and you bring them on board, and then you don't have the resources to support their needs, they very quickly get disgruntled and leave. And I've seen that happen at companies too, where we find the unicorns, we tell them, oh, you're going to get to work on these great projects, and then we say, oh, but you have to do it with a Commodore 64, and it just doesn't work that way. It just doesn't work. I would humbly think the biggest thing I look for in data scientists are people who want to learn new things and who love challenges, because that's what data science is really about. No one problem is the same as the next one. And if you get intimidated by, oh man, I don't know what I'm doing here, this is different than my last job, you'll never succeed. But if you get, jazzed by, wow, I've never seen something so screwed up in my life, I can't wait to dig in and see what I can figure out and fix. And you have leadership that supports you with that, and lets you fail. I mean, that's the other thing. You're going to fail more than you're going to succeed, but that's how you learn. You try something out, you experiment, you go, oh, that didn't work, let's try this. And you don't give up. You just keep trying things. I mean, one of the biggest traits of data scientists is they're called hackers. And I don't mean hackers like in the nefarious, hack the Skynet program or something, or take over, Wall Street. I mean, you have an axe and a big tree, and you got to take that tree down. And it's not going to be one stroke. You're going to just keep hacking at that trunk until it falls over. That's what a hacker is. That's what a data scientist is.
Love it. So why would you, if a customer, a client, a prospect of ours is coming up to Archetype and they want to know, they go, why is data science important for us? What would be kind of your response to that question?
I think the simple answer is because you're putting data and some sort of quantitative rigor behind your decision-making process. CEOs and C-suite people have great guts. They go with their gut, but you can't go to your shareholders and say, I went with my gut. it doesn't work that way. I mean, that's what I had. That was my chief job in the military. Is I worked for some incredibly intelligent general officers, but they needed me to basically back up their intuition with data. Yeah. And sometimes I'd have to have that uncomfortable conversation to say, hey, boss, the data doesn't support your intuition, and here's why. And I had to be humble enough, and trust me, this happened to me on more than one occasion, for them to say, yes, but you didn't consider this aspect, and I know the system better than you. And it was because I didn't look at the right data. And so it really is a back and forth. A good data science and decision maker relationship will be back and forth, constantly challenging each other and critiquing each other for, why are you doing what you're doing? Because I know the system should act this way. Well, wait a minute, the data tells you this. Well, you're not looking at all the data. Here's some other data you should consider that I know about, because I've been the CEO for the last decade. I know what my company is capable of. And that's where data science really comes in. We're the advisors from a quantitative standpoint to the C-suite.
I like that.
You know, it's almost like we've gotten really far past that automation is important for companies, right? Like everybody's just like, of course, automation is really important. Well, data science is really just automation with different inputs, right? And different outputs. It's not strictly if-then statements and RPA, you know, where this action leads to this. I mean, it is like, this action happens and it leads to this thing, and then downstream, this PDF gets made and an email gets sent. Well, now it's customer applies for this particular mortgage, and they fill out all this information, and then a statistical model or a predictive model gives an answer. And it's a form of automation, but that form of automation is constantly evolving. And so if you want to be even mildly competitive in your industry, you need to take full advantage of the automation around your data process. And I consider data science maybe the most important part of the automation around your data process. I mean, even how you keep data, right? How you store data, how you use cloud resources, all these things are a data science question. And so, you know, we work with email security companies. They're embedded in their product, their data science. You know, is someone typing nefarious stuff inside that email that indicates whether this is a likely to be a bad agent, you know, bad player, or they can do something nuts. You know, that's a data science question. How you write determines whether you've got bad intentions. Like all this stuff. There's all these things can be construed as data science questions.
Totally. I feel like I've always thought of it as similar to how we're in this like information age of everyone's always now saying like we have so much information available to us at any moment that borderline it's making us dumber as a society, people say, where I feel like a lot of corporations are getting to that point where they're getting so much data that they have as a corporation that if they don't get a rein of it with a data science, AI, machine learning, and really at least create a roadmap and a plan for that, it's going to be the same thing as we are in an information age for them as a business. Like, you feel like that makes sense?
Oh, totally. I mean, we worked with a client who had a ton of data, and they said, surely you must be able to help us determine whether or not our customers are going to stay with us or they're going to churn, because we have all this data on client behavior. There was no signal in that noise. The data wasn't the appropriate data, or it wasn't collected consistently enough or for long enough time period to have any signal in there that said, yeah, this is a behavior that indicates they're not going to stick around or they are going to stick around. So just having data is no good. You need to understand it.
Data is not synonymous with information.
Yes,
right?
Exactly.
Like they're different things, right? And so when you apply human analysis and judgment to data, you create information. And so we're being inundated in society with distractions, and distractions make it really difficult to make any sense out of things. And so a good data science process can in some way free your resources up to be less distracted by stupid stuff. I almost broke our rule, Mitchell. You know that. All right, but they keep us. You know, they keep us from, just like our robotic process keeps an individual from having to like reconcile these books at the end of the month because the tool does it for them. The same is true for a call center. Like, here you go. This is I'm a call center at a collection agency, and if I'm left to my own devices, I get a list of all the people that are delinquent, and then I just start at the most delinquent and go down to the list. But like, is that a good way to do things? I don't know. Maybe, maybe not. There's probably a better way to order that, right? Do I order it by the ones that are most likely to pay? Do I order it by the ones that are least likely to pay? Do I order it by the ones that are maybe most likely to be a little delinquent times the amount of money that they owe me? You know, like, all of these are different ways giving me different orders.
Or do you try to identify the people who are about to be delinquent and prevent them from being delinquent and just write off the delinquencies or sell them to a third party and save yourself the headache? I mean, this is where data science comes in, because you help the client ask even the right question. They might not be asking the right question.
They give it to, they let their reps go, and then they just like go down the list, top of the list. And guess what? Every day they call the same people.
Right? And to bring it back to economics, Ken, it's all about incentives. Yeah. If the incentive is to call as many people as possible, I'm going to call the easy people, and I don't care what the result is. But if the incentive is to collect as much money, well, then I'm going to go after that one big fish and work really hard on them and write off the others. I mean, this is where working with the C-suite and the leadership to understand, okay, what are you really trying to accomplish? Are you trying to collect more money? Are you trying to, say we're really good at closing deals? I mean, there's all these different things. It's the incentive structure behind it.
Awesome. So we're wrapping up on time. Last question I'll kind of go into for each of you. I mean, if we have a C-level executive listening to this, is really debating how to get started with data science in their organization, where do they start?
It's a good question.
Besides obviously calling Archetype.
Yeah, give us a 30-minute phone call. What's Davenport's book's name, Marty? That competing on analytics or something like that. I think that's what it's called. I may be twisting it around a bit, but that's a good place to start. There are a number of different executives and analytics courses at universities. I used to teach. I've taught a couple different ones that do a nice job of overviews of industry. I don't know. I think a phone call is a good idea.
Yeah. I think, as trite as it sounds, do a quick Google search on what is data science and for your particular industry, and see, read some of the advertising. You're going to get a lot of advertising stuff, but read some of the case studies or the use cases out there for your industry and where data science has helped. And then you need to call a professional. I mean, you need to talk to someone like us and just spend a little time. It doesn't have to be super technical, just the proverbial talk over a couple beers. Hey, Marty, I hear, you and Ken do this data science thing. What could you do for us at Widgets R Us? And, here's, and we would want to know, what kind of problems are you facing? What kind of data do you have? What are you willing to invest? Because it's going to take an investment of resources. And if you want to take data science seriously, you got to be willing to invest. And I'm not talking millions of dollars. I'm talking, people, and just tools so that they can, for lack of a better word, dabble in the space and see what they figure out.
Marty, one of the pieces of advice I've given some of my clients in the past has been, well, how many job recs do you have out there right now? They'll say like 100 or 200 or whatever. Like, how many of those are replacing somebody who has been here for 25 or 20 years doing the same thing? Like, I would bet you could automate a lot of that type of job. Like, what if you just thought about every job opening that you have, regardless of what type of function it is actually just being a data scientist? Like, just slap a data scientist name on the top of it and get more of those thinkers in your organization, because those thinkers are what's important.
Absolutely.
Thinking like a data scientist, I kind of believe we can train everyone to think like a data scientist. And it's as simple as what I'm about to tell you, which is cause and effect. That's it. Like, if I turn this lever, I get this outcome. Like, if you just start thinking that way, not like I just want to focus on these outcomes, which is the unfortunate thing about KPIs and KRIs and all these other metrics. Like, okay, great. My little KPI went up or down. Like, okay, great. It did that on the dashboard. That's cute. But like, what lever did I turn to get that outcome? And if I really want to improve this thing, like, what other levers can I monkey around with? And like, just start thinking that way.
Yep.
Right? It's not this outcome that manifests. I mean, it comes from somewhere.
Yep.
Like, my pricing caused my revenues to move around.
Yeah.
My incentives caused my reps to quit.
And it really stems from someone who's curious to look at that stuff and willing to, be investigative, be a detective, and try things out, see what happens. Don't bet the farm, but, take little experiments, take little steps, and then correct accordingly.
Yeah, totally. I feel like, I know Accenture had the study that they did when they saw that 84% of the C-level executives believe they won't reach their business strategies without even like scaling data science and AI, yet only 16% actually made the shift to actually start experimenting and creating an organization powered by it. But those same 60% were the ones where the top performers were achieving nearly three times higher in investment than the low performing counterparts. So it definitely shows how valuable it is to an organization, for sure. Awesome. Well, I appreciate both you guys coming on. We'll definitely be doing this many, many more times with you guys. And thanks everybody for tuning in, and we'll see you guys next time.
Thank you.
All right. Thanks again.